In this lesson, we're going to take a look at debugging. And I'm going to use the Linux debugger, and here I'm using the debugger GDB. The first thing is, we've got this program that we were using before, buff.c. I could actually take a look at buff.c. First of all, let's compile it here. And we're just going to say, buff and buff.c. And so now we could do GDB buff, and we could actually run through this, and it will run. And we don't have the ability to see actually where we are, though. I can't actually see any of the source code here. I don't really know where I am. It's sort of a bit like flying blind. So what I can do now instead is I could compile this with debugging symbol. We're going to add the debugging symbols in. Now we're going to go into GDB and buff. And now I can do a list and I can see where I actually am in the program. In addition to that, I could actually set a breakpoint. So what I want to do is I want to set a breakpoint on line 6, which is the very entry point of main. So now if I were to do a run, it's going to tell me I've got a breakpoint. I want to do a step now, and it's printed this value out. You'll see actually that it skipped over these two declarations here because this is really the first executable line. This is actually where we broke. We skipped right over these because there's actually no processing involved here. We're going to get to an executable line and then it's going to break. That's actually where we did the breakpoint, was at the printf. I did a step and jumped into the next line, which is the scanf. And now I'm going to say step again because we haven't actually run the step. We've actually just jumped to it. Now we're actually running the scanf line. And here's actually where I can put in the %x%n. And now we're at the string copy line. I'm going to say step and we're going to execute that. And now we're at the printf. I'm going to say step there. Now I can do a backtrace and see actually what we did. You can see main called printf, which called another function called vfprintf. And with a backtrace, you actually read from the bottom. The top, because it's a stack orientation, the top is the most recently called function, and then we run back until we get to the one that was least recently called. We can do all of those things. And that's with just a program that we can run. Now, the other thing that we could actually do here is we could actually attach to a running program, which is kind of nice. Let's see what we've got here. Let's see if we get anything better if we run as administrator. And looks like I'm not seeing much of anything here. Let's take another look. And here we've actually got something that we could probably take a look at. Let's find a function that we actually want to jump into. And this one looks okay. We're going to jump into this one here. I need to run as administrator here because it's a root level process. And now I can do attach to this process here. And now we're actually in the process that's running. Once you're attached to that process, you're actually running it through the debugger, and it's just like what we were doing before with that static program. If you knew what was going on, you could set breakpoints, you could inspect variables, you could do all of the things you can do in a debugger, just that this is actually a running program. And this really helps you if you were doing some reverse engineering, for example, on the Apache web server, or maybe on the Samba server, or something like that. You wanted to actually see what was going on with the service while you were doing some attacks with it, so that if there was a crash, you could actually see where the crash happened, you get the address and the function, be able to do a backtrace, all of those sorts of things. That's how you would do some debugging under Linux.